All right, we're doing three-dimensional figures today. As a warm-up, we're looking at some of these figures here. Can you remember what these are? I bet some of these you've got. I bet you've got this one nailed, but do you know what this one is? Or how about these ones? I bet this one, you've got this one, I bet. And I bet this one too. What about that one? Okay, well this first one was a triangular pyramid, and we name it that because it has this base right here. Probably need a bigger, thicker pen. Let's see. It's got this triangular base here, and it's got another base of a triangle down here, connected by rectangles in between. Any two bases that are the same, connected by a whole bunch of rectangles around it, is a prism. And then we name that prism by the same base, whatever that shape of the base is, even if it's not sitting on it, okay? All right, this one's a cylinder. Then we've got a cone, a sphere, and then did you get that it was a rectangular pyramid? I bet you got it was a pyramid. But again, pyramids, just like prisms, need to be named by their base. So we need to name it by what it's sitting on, what that shape is. All right, so we are going to be, not looking at that one, but calculating surface area and volumes. So a polyhedron is a closed three-dimensional figure made up of flat polygonal regions. Let's see, the face of a polyhedron is a flat surface on the polyhedron. An edge of a polyhedron is a line segment where the faces of it intersect. And a vertex is the intersection of the edges of the polyhedron. The bases of a prism of a cylinder are two parallel congruent faces of a solid. And the base of a pyramid or cone is the face of the solid opposite the vertex of the solid. So these words, face, edge, vertex, base, we're going to be using those a lot. And we're going to show you some pictures just to kind of nail those in. Okay. So a prism is a polyhedron that has two parallel congruent bases connected by a parallelogram face. And a pyramid is a polyhedron that has a polygonal base and three or more triangular faces that meet at a vertex, a common vertex. A regular pyramid has a base that is a regular polygon. A cylinder, a solid figure that has two congruent and parallel circular bases connected by a curved surface. Bet you guys know that one. And you guys know a cone. It's got a base, a curved surface that meets up at a vertex. And a sphere is the set of all points that are equidistant, which means equal distance from the center point. It has no faces, edges, or vertices. Polyhedra, or polyhedrons, are named by the shapes of their bases. So all of these are named by the shapes of their bases. Triangular, rectangular, and this could be any of them. Look at that. You could pick any of those to be the base. Pentagonal, triangular, rectangular, pentagonal. There we go. All right. And a polyhedron is regular if all of its faces are regular congruent polygons and all the edges are congruent. Remember, regular polygons have all the same angles, all the same side lengths. There are exactly 5 regular polyhedra. They're called platonic solids. We're not going to make a big deal about these. Not a big deal. Okay? Make that a little smaller here because Plato used them extensively. But we're going to tell you what they are right here. There's a tetrahedron, which has 4 equilateral triangular faces, or hexahedron, or cube. Octahedron, 8 equilateral triangular faces. Dodecahedron with pentagons. An icosahedron with 20 equilateral triangular faces. That's pretty cool. Okay, so let's go to example 1. Determine if this is a polyhedron. Then identify the solid. If it's a polyhedron, name the bases, faces, edges, and vertices. Okay, so let's look. This solid is formed by polygonal faces. That is, it has to have polygonal faces, so it is a polyhedron. There is no base, but the solid has 8 equilateral triangular faces, so it is an octahedron. The base is none, a whole bunch of faces. They use this shape to tell you it's triangle. That means triangle. And those are the edges, so segment, and then it's got vertices. The solid has a curved surface, so it's not a polyhedron. It's a cylinder. Okay. We're going to go on to example 2. Identify the 3-dimensional figure that can model this. This is a bigger part. What shape would be best modeled by this? If I wanted to know what kind of volume could be held in this, what is the best shape? Well, that shape looks a lot like a cylinder. And because it's curved, it's not a polyhedron. So, tell me which 3-dimensional figure can model the top of the camping lodge. And is that model a polyhedron? Go ahead and pause me, write it down, and then unpause. Did you say a triangular prism and that it is a polyhedron? Hope so. Woohoo! All right. Now, often a geometric figure is used to model a real-world object to estimate a measurement. Surface area is the sum of the areas of all faces and side surfaces of a 3-dimensional figure. And volume is the measure of the amount of space enclosed by a 3-dimensional figure. So surface area, it's how much space is on the outside, what we can touch. And volume is if I were to fill it up with water, how much water could I fit inside? How much space is in the inside? Okay. We're going to learn a lot of surface area and volume equations at the end of geometry, but these are the basic ones, okay? These are our basics. And those are all given for you on your note page, okay? These are the ones that are probably pretty good to know right offhand, but we will have these. Where's my given on the formula sheet? Okay. All right, so let's go through some of these. P equals perimeter. Whenever you see that. And H is the height. And B equals the area of the base. Look at that. Oh, they've got all that down there. Ah, Mrs. Cruz. There you go. Things you need to know. Height, always perpendicular. Perpendicular to base. Always. Okay? Other things you need to know. Let's see. Slant height. Slant height. It's going to be along a face. So you see here in a pyramid, this slant height, that's not through the middle of the pyramid. That's going to be along the edge, along the side. So if you were to put a measuring tape from the very tip to the very side right there. Okay? That's not the true height. Whereas this cone height, they're running a measurement from here to the center. That's a height. Whereas this L for the cone, this slant length, is running from here to here, right there. That's a slant length, or a slant height. The L, actually, they usually call it a slant length. If you want to know what the L is for, slant length. There you go. All right, so those are all your equations that you're going to be using here. Surface area and volume. Okay. Okay, so let's look at example 3. Find the surface area and volume of the cone. Round each measure to the nearest tenth if necessary. So, surface area and volume. If we were to go up to cones, I'm going to come up here. I'm going to erase some of my mess that I did. I'm going to grab these, copy, bring it down here. What do I need to know? I need to know my radius. I need to know my slant length. And I need to know my height, because that's what I've been given in here, right? I need to know, yeah, radius, length, height. Okay. What have I been given? I've been given this one and this one. This is my height. And this is my radius. So my height is 8 inches. My radius is 15. How do I find my length? What I'm going to do, let me look over here. My length would be from the top to the bottom, right along there. And the best way to do that then is to finish a triangle here. I'm going to grab a different color. I'm going to grab pink because I think that stands out pretty well. I'm going to drop one down here for my height. Oop, I don't think that went as well. Let's go from the middle. Okay. And across. 90 degrees. That triangle, that is 8 over here, 15 on the bottom, and has a length there, is a right triangle. Look at that. That's how we're going to find our slant length. We are going to do the Pythagorean theorem. A squared plus b squared equals c squared. Remembering that c is the hypotenuse. Right here, that's c. This can be a, this can be b. But just remember, my hypotenuse has to be across from that right angle. So we're going to fill it in. We're going to go 15 squared plus 8 squared equals my slant length squared. I'm going to square root both sides. And my slant length is going to be the square root of 15 squared plus 8 squared, which is square root of 15 squared plus 8 squared. 17. There you go. Now I've got enough information to do all of that solving, and I can just plug it all in and solve. But that's going to be very common. They are not going to give you all of the pieces of information on cones or on pyramids. They will make you solve for a missing piece of information. Same with pyramids. Okay. So this walks you through that. They're then going to use that to solve. Here's our surface area where they plugged it in for the radius and the length and the radius, and they found about 1,508 square inches. And then for volume, they plugged in their radius and their height and got 1885 cubic inches. All right, now go ahead and find the surface area and volume of the rectangular prism. Go ahead and pause me. All right, and did you find those numbers? Surface area 286.4 centimeters squared and volume of 312 centimeters cubed. All right, let's go on to another example. 4. New Year's Eve. The New Year's Eve ball is a geodesic sphere that is 12 feet in diameter. It weighs 11,875 pounds and is lit by a lot of LED lights. It's covered with 2,688 crystal triangles. How many lights are contained on the ball's surface within an area of 4 square feet? Tony's repairing a section of the ball that has a volume of 8 cubic feet. How much does that section weigh? Okay. So, how are we going to do this? How many lights are contained on the ball's surface within an area of 4 square feet? So if we know, we need a plan. If we know the total lights, then we need to know the total square feet. And then we need to cut it down to just 4 square feet and find that percentage of the lights. Okay. So that's what they're going to do. They're going to find the surface area. Because the diameter is 12 feet, the radius is 6. Make sure you're watching for that. Change it into 6. Okay, so our surface area is that much. 452.4 square feet. Okay, determine the number of lights within an area of 4 square feet. So if we've got 4 feet squared, and if we've got this many lights to a ratio of 452.4 feet squared, and notice that the feet squared cancel. Those units will cancel. Now we take 4 times the 32,256 divided by 452.4. And we get this number, which we round down to 285 lights. So about 285 lights within 4 square feet. All right. Now, Tony's repairing a section of the ball that has a volume of 8 cubic feet. How much does the section weigh? So let's find the volume. So we put in the volume. We know that that radius is 6. So we find the volume to be 904.8. And if we know that the entire weight is that many pounds, and the entire volume is 904.8, we can set up that ratio and cancel the 904.8, or cancel out the feet cubed, and find that it is 105 pounds. Okay. Last practice, Mateo's pool. Not last practice, there's 2 more. Mateo's pool. Mateo's family is building a new in-ground pool. A cross-section of the pool is shown. What is the volume to the nearest tenth? And then they need to install a protective liner to cover the walls and flat base of the deep end of the pool. How much liner is required to cover the deep end of the pool in square feet? Okay. So a protective liner covers the inside before they fill it up with water. So you're going to cover all of the parts that the water touches inside the pool. Go ahead and pause me. Do the math on these. If you need a hint for this part A, you can break the pool into different sections. Like you could go ahead and break it into like shapes that you recognize, if that helps. Right. Did you get 3,142.5 feet cubed? And did you get A? All right, last one. Destiny visits a water park where a new cyclone water ride has opened. On a new ride, a tunnel flows into a large funnel. The slant height of the funnel is 29 meters, and the surface area of the funnel is 910 square meters. When the funnel is at its widest, what is the diameter? Round your answer to the nearest tenth. Okay, and I don't actually have this answer written down, but I think I'm getting 7.9 for the radius, 7.9 meters. So that would make it, what would that make it? 15.8 meters for the diameter. There we go.